Second derivatives. So with second derivatives, what we do is we differentiate once and then we differentiate again. Example 9. Find the second derivative of each of the following with respect to x. So we've got our part A of x equals 6x to the power of 4 minus 4x cubed plus 4x. So let's do the first derivative. 6 4s 24, x cubed minus 4 3s are 12, x squared plus 4. And now we're going to do the second derivative, so 2 dashes, and we're going to differentiate that one. 24 times 3 will give us 72, x squared. 12 times 2 is negative 24x, and plus 0, so I'm going to get rid of that. So there's my second derivative for part A. Part B, y equals e to the x sine x. So here we've got a product rule, so when we differentiate, we make sure that we differentiate one and then leave the other one. So we've got e to the x, differentiating that, e to the x still gives me e to the x, and I've got sine x. Now I've got to do the other one, so plus, differentiate sine gives me cos, and leave e to the x as it is, so cos x, so there's that one there. And now I'm going to do d2y divided by dx squared. So again, I'll differentiate e to the x, which gives me e to the x, leave sine as it is. Now I'm going to differentiate sine, so it gives me cos, and e to the x stays as it is. But now I have to do this one here. So again, I'll differentiate e to the x, which will give me e to the x, and leave cos as it is. And now I'm going to differentiate cos. When I differentiate, that gives me negative sine x, and e to the x is still there. So now that and that cancel, and e to the x cos x plus e to the x cos x is 2 e to the x cos of x. I'll put that in brackets now to make it easier for us to read. You can do the second derivative on the calculator by going to that symbol with the boxes and then putting your D2 in there, so you get that type of thing, and it will work it out for you. Example 10. If f of x equals e to the 2x, find f double dash of 0. So we need to differentiate twice and then put x equal to 0. So f dash of x or equal to, because I've got to differentiate that, e to the 2x. F double dash of x or equal, well, 2 times the 2 gives me the 4, e to the 2x. Now we want when f double dash equals 0, so I'm going to get 4e to the 0. E to the 0 is 1, so I get 4. Number 11. If y equals cos 2x, find a simple expression for this one here. So it looks like we need to get to y dx and then square it and do the double derivative here and square that double derivative. So let's just write y equals cos of 2x. Let me do the first derivative, so dy dx, because I'll need that. Differentiating cos is going to give me negative. Okay, and it'll be sine, but I've got to differentiate inside the bracket there, so that will give me 2 sine 2x. So there's that one there. Now the double derivative, d2y dx squared. So again, differentiating sine will give me cos this time. So I'll still have the cos 2x. Differentiating inside the brackets is 2. 2 times the negative 2 that I've already got outside is going to give me negative 4. So there's that one there. So dy dx all squared plus 1/4 d2y over dx all squared squared equals y dx. I already know it's negative 2 sine 2x, and I've got to square that, plus 1/4 d2y dx squared is negative 4 cos of 2x all squared. Negative 2 squared gives me 4, and I've got sine squared of 2x. There's that one. Plus 1/4. negative 4 squared, I'll put this in brackets at the moment, is 16, and I've got cos squared of 2x. So a quarter times 16, I'll get rid of that bracket now, is 4. So I end up getting 4 sine squared 2x plus 4 cos squared 2x. Now this is a double angular formula. I can take out the 4 and I get sine squared 2x plus cos squared 2x, and sine squared plus cos squared gives me 1. So that's just 4 times 1, which is 4.